Assalamualaikum and hello. Now I'm going to continue our next video still about subtopic 4.2 stoichiometry, where in this video I'm going to teach you how to do the stoichiometric calculations in terms of volume of gases at STP. So let's try to do example 3 together with me. So example 3, I've given equation where this is my equation from the questions, and I have to do two questions here. First one, I want to calculate the volume of oxygen at STP produced from 1000 gram of C4H10. So C4H10 is known as butane. So how to calculate this, how to do these questions? First thing first, you have to get the balance equation. So lucky for us, the equation is already given, but we have to check whether it's balanced or not. So as I can see here, my equation, I got 8 carbon, and then here I got 8 carbon, and then I got 20 hydrogens. So I got 20 hydrogens here, and I got 26 oxygen, and I got 16 plus 10, also 26 oxygen here. So it's balanced. Now I'm going to copy the equation back in my answer scheme, where in my answer scheme I have to compare between two things. In this case, when we want to do the stoichiometry, as usual, kita akan compare between dua benda. Dan one of them is given and another one more X. Kita yang perlu cari. So how to do that? I got between oxygen and butane. So what is given from here is the mass of butane, and I have to calculate the volume of oxygen. So what is the volume of oxygen at STP, the one that I need to find out, and then mass of butane 1000 gram is given. So what I should do first, from this information saya hanya ada mass untuk butane sahaja, and as I mentioned in the previous video, everything must go through moles. So maknanya daripada mass 1000 gram of butane, we have to find out the number of moles of butane. So I got here 1000 gram divided by 58.0 gram per mole. So try to get rid one extra zero there, it's typo. And what I have here is 17.2414 mole. And the next one, I have to do the stoichiometry. So the stoichiometry between two of them, butane and oxygen. So I put the moles for butane and oxygen based on equation first. So I got 2 mole of butane and 13 moles of oxygen. So this is from balance equation. This is how I write it down. And the next one, I have 17.2414 mole. Make sure you calculate in 4 decimal places. Please, wajib 4 decimal places. Jangan bunda terlalu awal. And the next one, I need to find out X mole for oxygen. So what I have here, this is it, the second line for my stoichiometry. And then I rearrange to find out the value for X, which is 112.0691 mole of oxygen. I know the value is very big, but if you got the correct way of calculating that, which means you are still on the right path. So now I got the moles for oxygen. What I want to find out is volume of oxygen at STP. So in order to do that, you have to use the formula when you have the mole, how you want to calculate the volume. So the volume of oxygen at STP is where I times with the molar volume at STP. So the mole must be times with the 22.4 dm cube per mole. And I cross the units for mole. and per mole. Yang tinggal hanyalah dm cube. So this is my value 2510.3478 dm cube, ataupun another unit yang sama dengan dm cube adalah liter. And then, as I mentioned before, if the equation is given in the questions, you have to double check whether it's balanced or not, because sometimes dia ada trick dekat situ. Dia bagi equation tapi dia tak balance. Tapi bila awak ignore that, you are going to do the wrong stoichiometry. So please double check. So next one, settle untuk kita punya question A. And from the same equation, I want to do the question B, where I need to find out the volume of CO2 formed at STP. So it's by referring to A. So from A, what I have here adalah mass untuk butane dan mole yang kita sudah cari. Sekarang kita akan compare butane yang telah diberi dan kita calculate bersama dengan CO2. Bukan lagi oksigen, kita ada dalam case question B adalah CO2. So this is what I have to find out, volume at STP for carbon dioxide. So how to do that? So straight away kita dah ada mole given for butane. So maknanya kita boleh tentukan kita punya X, iaitu mole untuk CO2. So do your stoichiometry. Ingat, ayat pertama adalah from balance equation. You got 2 moles butane produce 8 mole CO2. And then from what we calculated from A, 17.2414 mole of butane, and this is what we have to find out here. And rearrange, you will have your X value is 68.9656 mole of CO2. And now we got the number of mole. Same concept from before. You want to find out the volume of CO2 at STP. So you have to use the mole times with molar volume at STP. You will have the volume for CO2 adalah 1544.8294 dm cube. Ataupun unit yang sama seperti dm cube adalah liter. So choose whichever you want. But the most important thing that you have to know that you should memorize all the formula to calculate the number of moles that you've learned so far in chapter 3, because we are going to use that throughout this stoichiometry subtopic. And everything must go through moles. As you can see here, I always said to you, you have to take a look at the information given, dan kita akan gunakan mole ratio untuk cari apa yang kita mahu, what we wanted. And this is going to be our X. So that's all for this video. So for the next video, we are going to learn the third examples in stoichiometric calculation. So that's all from me. Thank you for watching. Bye.